and welcome to Metro Home Theater Tech Tips. I'm Brent McCall, and socially distancing from me is...
Adam Rogers.
Just so everybody knows, because we are following the rules.
Yep. Got a full...
We're at 6 feet.
Oh, there we go.
We're
6 feet. Hey.
Just want to let everybody know
There
we're
we go.
following the social distancing rules, and we're going to do our best to make sure that none of us here get the COVID-19.
Right. So just real...
Go on.
I was just going to say real quick, well, you were about to say it too, but last episode we had some troubles with the audio, so sorry about that. On Friday, pardon me. On Friday we had some issues with some audio, and we found out what the problem was. It turns out we were having, pardon me. We were having some issues with a power supply. We think there's still some more going on with it. We're going to figure it out. We've made some changes to ensure that we have audio now, so sorry about that, but we're back. So hopefully you can hear us.
By the way, goes on to a previous episode where we had troubleshooting and we discussed grounding problems.
Right.
So what we found is we, in fact, have a ground differential between that side of the room and that side of the room, which was dumping 98 volts down the coax feed because of a ground issue.
Yeah, so there's actually a good chance that the laptop that I use right here to actually change the cameras and everything, it's a really good chance we burned out the USB connections on it. We have another laptop over on that side where you guys can't see that's now running everything. So
troubleshooting 101.
Yeah.
And by the way, we did take some video of our process on this last week that we will do something with to get out to you guys to show you what we did and how we figured out what was going on, particularly when we grabbed the coax and it lit us up.
Yeah, that was interesting. Then unplug something, you grab one side of it, grab the other side of it, and you get lit up with 98 volts. You know something's wrong. So
it happens everywhere in the world, not just on the job site, so you do need to be cognizant of those issues. But let's get into why we're here today, which is HDMI 2.1 and the transition from where we are to where we're going.
Right. So as before, last Wednesday we had this discussion. We had part one. So today we're going to continue on that discussion. Some of the things that we wanted to talk about that we didn't get a chance to really dive into last time were the extenders going longer distances.
Yes, sir.
We're talking about the actual HDMI products, the electronics of them. So that means splitters, switches, and different devices that will handle that as we move into the 2.1 world. And then we also wanted to dive in a little bit deeper into the actual makeup of what the HDMI signal looks like.
The questions last week gave us a lot of places to go. One of them, which was an excellent question, was about eye patterns.
Yes.
And then we had another one on EQ. And we're going to cover both of those today. And once again, we have a giveaway. This week again, the HDMI surge protector. But I believe we picked last week's winner. Now, I don't remember the name, but I do remember the question, which was...
It was the one about, I believe it was about the eye pattern.
It was about the eye pattern.
That's right.
Yes.
So we in the description below, we're going to have the winner about that one. So get back in contact with us, or we're going to try and get in contact with you. Again, as we move forward with this, we are going to be doing a giveaway. Today, again, like Brent said, we're going to be doing another surge protector, the HDM SP3.
Yes, sir.
And so definitely keep an eye open for that. Ask your questions, give us your stories, do your little tidbits and stuff in the questions and comments and stuff. So as we move along, we'll get to see those.
Questions are very important for us, and they really help guide where we go with the videos. Now, unfortunately today, normally Adam and I work together on the whiteboard, but due to the new social distancing requirements,
right,
what you'll see is when we go to the whiteboard, it'll just be one of us, the other one will step back,
right,
take a break, have a drink, go to the restroom.
Hopefully mute your mic before you do that.
Really?
I'm just making sure. Just making sure.
So we have a lot to get into. So let's get started with last week's winning question, which was eye patterns.
Right.
Because they have changed dramatically from the early days of HDMI to now. So we're going to switch to the overhead, and I'm going to go to drawing.
Let's see. We're going to go over here to overhead. 1, 2, and 3. Look at that nice little transition, right? Isn't that? Okay, go ahead.
So we're going to start. I'm going to start at this end of the board because we have a finite amount of space. And we're going to talk about time and distance, because that's what this is all about. When you're looking at an electron, we're going to assume this is an electron flow. The speed of the electron, the data, does not change with bandwidth. What changes is how many lanes of data are passing at a given time so that enough data can get there to build a high-resolution picture. Now, as we mentioned, because the speed does not change, the eye pattern has to. So before, we could have a larger eye pattern because we didn't have to send, the data had the time to get up, get over, and get down, so they could have a larger eye pattern because we had a bigger time space. This time gap was large. Now, as we have increased resolution, that time gap gets smaller. So the data does not have as much time to get from here to here as it used to, or to get back down. So what will happen is the eye pattern gets smaller and smaller, so the data does not have to go as high to get read. Now, as we get into the moving forward into 2.1 and 48 gig, that eye pattern gets very small. And plain and simply because we no longer have this space, the eye pattern, now we have this space. So it has to transition from low to high and back down to low in a much shorter period of time.
And like we said on the last episode, that's basically the same thing. We have to send that same amount of data. In fact, more data
Much
now.
more data
We're sending a lot more down that same, but we're now decreasing the amount of time that we can send it because we have to send more data. That's where that bandwidth comes into play.
Right, so this right here is the time. And each time we transition to a higher bandwidth, that time from point A to point B gets smaller. One of the classics that I used to do when training is I would walk to a door in a room, and let's talk about how many times you can open and close the door in a given period of time.
Right.
Now, if I have lots of time, I can open the door all the way and close the door all the way. But as my time shortens, I can't get as much door swing in the same period as before, because I need more door swings in that second than I had the first time.
Right.
So that's why it gets smaller and smaller and smaller. The drawback is, would you switch me back to overhead?
Yep.
As the data gets smaller and smaller, the ability to discern that data decreases. So you have to have much better extrapolation and understanding at the display side with relays reading that data and much faster relays at the source side sending out the data. Because all this really is an on and an off switch. Now the faster that switch goes, the closer it has to get between the on and off state to make the movements.
Right.
Are you guys with me so far? Do we have any questions yet?
No questions yet, but again, ask your questions if you have any. Let us know if you have any input on it as well. This is the perfect time for that. Yeah, social distancing. So with that there, definitely ask your questions. Let us know what you think about it. If you have any thoughts on it, let us know as well, so that we can kind of cover that.
One of the things we covered in the past was how important cable geometry is.
Right.
When building wire, whether it's copper or in the case of fiber, the circuit boards at the end of the line and the beginning of the line. Now, I'm going to switch to this side of the board.
Yep, go for it.
When you're looking at the data, you have to have very accurate, in the case of copper wire, you've got twisted pairs. And this point in the twisted pair is very critical because you need each of the links on both sides of that point to be the same. If they are not, you will have timing errors between the source and the display. On a circuit board, you have to deal with it the same way, and we've discussed timing errors in circuit boards, why one input typically works better than another for that reason. So, looking at your cables, we have to make sure that all those transitions are the same. Now, it's not just within a single pair of cables. You now have 4 high-speed signals doing that. And boy, that's a terrible drawing.
It's a good thing that you're not winding up these HDMI cables by hand.
And you have, yeah, absolutely. By the way, that would be a terrible cable.
That would be an absolutely terrible cable.
But we see them. So not only do all of these have to be the same, but they all have to line up with each other in order for the picture to arrive at the same point.
Now, we're talking about the physical makeup. We're not just talking about the frequencies as they go across the cable. We're actually talking physically the windings of the cable. So does that come into play? So say, for instance, I've actually got this one here as a proof of concept. When you have a cable that has an okay design and dimension to it, but then it has some kind of damage to it. So say, for instance, like this here, where it's actually got a pretty good kink in it.
Yep.
And that kink, and with this cable in particular, this is the one that I use to actually show white sparkles on the screen when I want to prove that there are white sparkles, or when I'm using it with another device that may help to solve that. This is part of our troubleshooting and part of our product development. It's one of the tools that I use. But with this here, that kink that's in there, if I just run a picture straight through, what's going to happen is I'm going to get white pixels across the screen. And so doing that, that's also what is being created when we're messing with that. When that's incorrect, or if someone's damaged it, that's where we see those
Absolutely.
white pixels.
Now, one of the things we've discussed, and this is very critical, because prior to now, you only had to get 3 channels to be reasonably accurate.
Right.
Because that's the way HDMI 1. anything all the way up to HDMI 2.0 worked. Is there were 3 active channels out of the 4 high speeds.
Right.
This was simply clock. Well, the world has changed going into 2.1. Now, for the first time, this 4th channel, which is called D3, must be equivalent to D0, 1, and 2 because it also carries high-speed data. Now, this is actually an advantage to the integrator and the retailer. And here is why. In the past, all 3 of these had to be equal. And they had to get the data at the same point, at the same time, with the same bandwidth, with the same twist ratios, a whole lot of saming going on.
Mm-hmm.
This created a lot of problems for the retailers because they would sell a cable that may not be good, and the TV would come back.
Right.
Now, your major stores don't want to get TVs back.
They don't make enough money.
They don't make enough money to take them back. So they pushed against HDMI and said, we need a better way. Well, HDMI came up with a better way. They're doing equalization curves. In the past, the EQ curves were basically a single curve for each channel, and they all matched up. That is changing. Now what you have is D0, D1, D2, and D3. Each of these will have 8 curves.
Now this is in 2.0.
This is 2.1.
This is 2.1. Okay.
This is 2.1. Now, each of these curves represents a different frequency, a different resolution bandwidth.
Mm-hmm.
So all 4 of these connections have these same 8 EQ curves.
Right.
Now, what makes this interesting is HDMI does not require, we think, because the CTS is still not released, but preliminary indications are, you don't have to have all 8 work on every single feature, on all of these feeds.
Right.
All that has to happen, we think, is 1 to work. So let's say this one is 1080p. Now that's the bandwidth of 1080p. Let's assume this one's getting maybe 4K 30. This one's getting 4K 60. And this one's getting just basic 4K. Again, 30, HDR, HDR. The big change going forward is, as long as some of these are working in each of these feeds, they will be considered a passing cable because you will get a picture.
Mm-hmm.
Whereas in the past, if one of these failed because it was red, it was green, it was blue, you had a failed picture.
Right.
Now on all these, every one of these is red, green, blue on all 4 of these feeds.
Which means that even if one of the channels is having problems,
the others can pick up the gap.
and you can actually get a picture.
Yes.
Now, it may be a lower grade picture. You may not be
Yes.
getting a full, say, 8K or 4K.
Right, and here's the thing. You'll still get a picture.
Mm-hmm.
As long as 1080p is working there, something's working there, something's working there, and something's working there, it's an aggregate of all those together. So you'll get a picture on the television.
Right.
Whereas if there's a problem on this one, the original feeds, you got sparkles.
Right.
That was a fail.
Right.
This is not a fail to the consumer.
Right. Because they can still get a picture.
Right. It may not be the best picture.
Right.
It may not be anywhere near the best picture.
Right.
But it's still a picture.
Right.
So the retailers love this.
So when we take this concept and put it towards what the dealers are going to be running into, what the installers are going to be running into, how does this affect them? And this, well, actually, more importantly, how does this affect the salesman when they're actually selling the job to the client?
Well, what they want to talk to the client about is understand what this is and let the client know, sir, honestly, when you go look at something and you pick up a cable, you know, your own off of Amazon or eBay or a retail store,
Yep.
you will get a picture.
Right.
The question is, are you getting the picture you should be getting, or are you just getting a picture?
So it almost feels like we're falling into almost an audiophile world at this point when it comes to video.
For the first time, you can legitimately show where a cable makes a difference.
Right.
In the past, as long as you got a lock on all 3 channels and there was no sparkles,
Right.
There were differences, but you had to be really well trained to notice them. It wasn't like component cables where you could see differences in blooming or red shift or white shift or black crushing.
Right.
Yes, there's still black crushing in HDMI, and the guys that do ISF are very, very cognizant of that.
Yeah. Yeah, definitely. And by the way, ISF, great thing to look at for all their stuff. Here for a lot of our testing stuff, we use the Meridio pieces to do a lot of our testing. That guy right there. But if you can, which unfortunately the last episode was, we were going to be talking about what to have on your truck.
And that episode failed.
That episode failed, unfortunately. We're going to go back to it, but this is definitely one of the pieces to have on the truck with you. You can get, they have the newer one now. It's actually the
less expensive.
Less expensive.
It's not set up for ISF calibration.
Correct. Now, but it's definitely good for using it for HDMI troubleshooting, and I have that down here. But these pieces are great. So when we do that episode, we're going to talk about these again as well. But what we do with them here is being able to test for those connections to it to see what's going on with it. But ISF is definitely part of the original Meridio testers. I think these are called the 6Gs?
6Gs.
That's right. So definitely check those out. But so when we're looking at that, we're really falling, like I said before, it's almost like we're falling into an audiophile world because we now have the ability to show, look, a better quality cable
makes a difference.
Makes a difference now.
It does for the first time, legitimately and demonstrable.
You're able to see it. You can actually now see the difference. Now, a trained eye from before, you could see the difference, but now we're actually getting into the place where you can actually, with data, show that.
Like, well, HDMI, digital's digital, it either works or it doesn't work.
Right.
We all heard that, and AVS Forum pushed it, and there's a whole lot of belief that all you had to do was meet the minimum threshold, and it worked.
Right.
And it did work. Mm-hmm. Unlike component or analog cables where you could see differences, herringbones, color shifts, things like that, if you got about 70% of the data, you've got a picture lock.
Right.
However, that's not 100% of the data. There's still stuff not there that adds to depth and detail. This takes it a step further. As long as you've got functioning EQ curves
there you go.
On all four channels, you have a picture.
Right.
Now, it may not be, because these are aggregate, because it's red, green, blue, red, green, blue, red, green, blue, red, green, blue. These are aggregate, meaning they add together for your total bandwidth.
Right.
So if this is 365, this is 10, this is 8, and this is 13, you add those four numbers together to get the total capability of the system because it's intelligent, or we expect it to be, and it will adapt to that.
Right. So in the instance where, say I've got a client who has an old Amazon or Walmart cable that they've put in that had the cheaper twist on the clock one, and they get the new Samsung or Sony 8K TV, and they get when it finally becomes available, an 8K content generator of some kind. Are they going to get picture?
They will get a picture, but it will probably be a 4K, or it will be a compressed 8K, much like DirecTV does for 4K.
Right.
And they'll use some level of DSC, display stream compression, to take that 48 and squeeze it down into 32 to 24.
Right. So Symphony cable, hashtag cable matters.
They always got good questions.
I love this. Cable matters. I love that. I'm writing it down. Uh-oh. Yep,
look at you.
Yep, get out of here. There you go. I'm taking over. There you go. Cable matters.
And it does.
I like that.
It always had, but it will matter more going forward because now you can demonstrably show the difference between a POS and a quality product for the first time.
Right.
To most people.
Right.
Now, if you, an ISFer, a guy that's really qualified and understands the colors and the shifts and the crush, he can look at it and say, you know what, that's not right.
Right.
Now you can be much more obvious with these differences.
So
let's say we'll get a picture.
Let's go ahead and jump to the next train of thought, and let's talk about the HDMI electronics, because right now, as things stand, there really are not HDMI 2.1 electronics.
And honestly, I'm a little concerned about this because we are seeing TV shipping with HDMI 2.1 chipsets.
Right.
But to me, this is a lot like the very first 4K sets that shipped.
Right.
And we're not going to mention any S starting brands. Well, them and the other S. Both shipped products that were 4K.
Right.
But they really weren't. They were 4K.
Right.
They didn't accept HDR. They didn't accept HDCP 2.2. And in the case of Sony, they actually sent a technician out to replace the HDMI board in your display for it to work with that round media player, which had a life of about 6 months.
Right. Right. Because at that point, all it was
4K,
a
30,
repeating
4K, 20, yeah.
media content. It wasn't actually,
Right,
movies
and you
or
actually
anything.
had to have a network cable to it and the TV for them to negotiate HDCP with an office in Hollywood.
That's great. Oh,
But
man.
you could get 4K, but no real HDR support, no HDCP support.
Right.
We are honestly concerned that running out and buying a full 8K TV today, because the standard still is not finalized even on the hardware. It's kind of like, remember Cat 7 4 or 5 years ago, you could buy Cat 7 cables?
Yep.
But the standard wasn't even ratified, so you really don't know if it's a Cat 7 cable, but it said so.
Right. Yeah. So the long and the short of it is that right now we don't have 2.1 electronics. We don't have extenders. We don't
No.
have splitters. We
No.
don't have switches.
No.
We don't have AVRs. I don't think any AVR companies come out. Cedia,
However, I honestly anticipate that what's happening with the global situation will impact product development and delivery.
Right. So with that, our hope, of course, just like any other industry right now, we're kind of slowing down because of what's going on. However, with that being said, we're going to be getting, hopefully soon, we'll be getting the actual electronics, but they still have to go through and figure out how. So, for instance, we have our GA2, and the GA2 has 48 gig capabilities.
As does our new fiber.
As does our new fiber. However, the thing is that with the electronics of the GA2, it took quite a bit of figuring out we're going to cram 48 gigs into that one little box. And that one little box, while it does do quite a bit, it's not doing so much as what the splitters and switches and AVRs are doing with the content.
Well, and then there's a whole difference in board material.
Right.
When you go from 24 gigs, which when you look at our GA1, our active cables, our fiber cables, our passive cables, the SP2, or excuse me, the SP3, the EDIDB3, the Junior 3, the AIO2, they are all 24 gig product.
Yes.
I just caught my mic cable.
Yes, you did. That was funny.
They're all 24 gig, which is 6x4 capability to take you right into 2.1.
Right.
To go to 48 gig means a whole different change in board substrate.
Right.
And board design, it's not just, okay, we take the same traces and change the board material. It doesn't work like that, because then you have RF interference between the traces.
Right.
So there's a lot more to control.
Now, so then at that point, so we're actually talking about the actual, inside the PC board, the different layers that we have.
Yes.
Physically, the actual material that's being used is going to have to change because we have a higher frequency, higher bandwidth requirements.
And as frequency changes, it also affects impedance, it affects thickness, it affects everything. It affects everything that's in there. It also infects a number of things.
Of course.
It affects everything that's in that design. So you're going to see a lot of changes coming as we move to 48. 24 is where we are right now. Really.
Yeah.
And we're going to be at 24 for a little bit. This is not we're here today and we're going all the way up there tomorrow. It's not going to be an instantaneous jump.
Right.
Manufacturers, from the hardware, from the cables, from splitters, matrices, all these devices have to adapt to this change.
Right.
And it's a significant change. So it's not an instantaneous flip a switch and we're there overnight.
Yep.
But at least for us, because we're already in the design phase with that new material, we know what's happening, where we're going. We still don't have a CTS for cables.
Right.
And that's a little bit disconcerting, but there's a whole lot of politics on that one that we won't get into.
Yep.
But we do know what the hardware expects.
Yeah.
And we can build to that expectation. So that's where we're going.
So with that, I guess to cover all that over again, when we get into the HDMI 2.1 world, finally, when things actually start happening, the good news is that overall getting a picture on the screen is going to be easier.
It actually is going to be easier.
Which is going to be great for you guys out in the field to make sure that, hey, I've got you a picture right now. There are some troubles with it, but you got a picture and everything's working there. If we want better quality picture, we got to look at better quality cabling, better quality connections, whatever it is. The downside right now, unfortunately, and as we move into the new technology, is that we don't have that new technology. So 2.1 video, 8K video and whatnot, it's not really here yet. We don't have any content to really put out there. When it comes to the actual splitters and switches and extenders, for going longer distances and whatnot, those aren't here yet. They're coming. They're going to be here soon, hopefully.
Right now, let's talk extenders, because this is something you brought up at the very beginning.
Yeah.
Extenders are going to be a tough one on this. You're
Yep.
gonna honestly want to start moving over to a fiber infrastructure,
Right.
because copper just has bandwidth and distance limitations. Any way you slice it right now, you're stuck at 10 gig on a piece of category cable.
Right.
So you have to do some level of compression. Typically it's two-stage, and we've discussed this in the past. Valens will go up to 13.65 and take that down to 10, and then there's something else above that, taking it from 18 down to 13.65.
Right.
And built into 2.1 is DSC, display stream compression. That is actually fixed as part of the standard going forward, which will allow you to take, for example, 24, 20, get it down to 10 with minimal loss.
Right.
Visually lossless compression.
And visually lossless, that's one of those terms that sounds amazing. However, if you have a side-by-side comparison,
It's not.
it's not. But when you have it by itself, even today's
looks good.
standards, it looks really good. Last time we talked about the Billy Lynn's long halftime walk video, the 4K 60 422 video. We actually took that video and sent it across regular HDMI cable, and we also sent it across one of our extenders. And you can definitely tell a difference. The extenders are limited down to a 10 gig, so they have to actually take that signal and compress it. So when you're looking at the video up in the sky, I don't have a sky screen here, but up in the sky, you can see that there's portions to it where you might get a little bit of banding. There you go. So you might get a little bit of banding across the skyline because you get a little bit of a different change because you have to compress that data back down. With an HDMI cable, it's not there because it's just going straight across. So like you were saying, as we move into 2.1, the bandwidth requirements, what's going to be interesting is the fact that we're still going to have to do that compression to bring things back down if you're going over a copper connection.
Even a good cable.
Even a good cable. And then at that point, we're also going to probably have to do compression on the fiber connections, because a true SFP module for a fiber connection right now, the highest that we have, one of the highest that you can get much higher, is a 40 gig SFP module.
There are 100 gig modules.
There are.
It comes down to cost and application for the job. And like with everything else, if you want to go high bandwidth out of the gate, it's going to be darn expensive at the beginning.
Yeah.
But if you look at where we are now with fiber versus even 3 years ago, the cost has come down significantly for the performance levels. So there has been a huge improvement, and we will see this happen. It's every day there's new things going on. There really is.
Yeah. So we do have one question.
Okay.
So we have a picture. How will
Yeah.
we know what the resolution is without a tester?
See, that's a tough one because TVs lie.
Yeah.
They will absolutely lie.
We learned about that pretty quickly.
Yeah, they'll tell you 4K or 8K because that's what the consumer wants to see.
Right.
And that could be from the metadata, not from the actual bandwidth of the signal.
Right. So you're going to run into a little bit of a problem. You're going to be able to see, okay, so we've got...
Kind of like online dating.
Right, exactly.
Yeah, yeah.
So, yeah. So a lot of times what will happen is when you turn on a certain source or certain display, what you'll see up here on the screen is, hey, it's 4K 60 or 4K 30 or whatever it is, or it'll tell you like the actual, pixel density on it. So unfortunately, while it may have that, it may not be, like Brent said, it may not be truthful. There will be testers out there. Again, that Meridio piece is a great tester. Now, unfortunately, that one that I showed you before is only a 2.0 and down HDMI tester, so it'll give you
It's
all of the
coming.
information there. But the 2.1 testers are coming.
Now,
So
there are also some sources that will allow you to look at bitrate output.
Mm-hmm.
And I think some of the displays at the higher end will look at bitrate input.
right.
And you can use that math to determine what am I actually getting.
Right. So one of the biggest things, of course, is and like I said before, it does feel like we're moving into an audiophile world. Audiophile in that world, a lot of that is subjective
Perception.
To that particular person. I might like the sound of this set of speakers with this set of speaker wire, and you might like a set of
Obviously, you're
speakers
an
that's
idiot
completely
because
different.
I know better.
Obviously.
Obviously.
So in that case, in some cases, you may find that your client says, you walk in and you're a trained technician. You look at it and you're like, this picture is perfect. Your client may walk in and be like, yeah, but I liked it before the way that it looked before.
Yeah, I want a little bit more green.
Yeah, and unfortunately, it's going to be, you may have to go into the settings and change the settings of
Let's
the
be honest,
color
how
settings on
many
the
times have
TV.
you spent the hours getting the room properly equalized, balanced? You go away, you come back, and they got the loudness button turned on.
Yeah, yeah. So Yeah, man. Symphony, you have been lied to. I can guarantee it. He says, well, then I've been getting lied to.
Yes.
Yeah, you have. Unfortunately, that's what it
However,
comes
the
down to.
customers are also getting lied to, so they're happy. Perception, look, if it says 4K, whatever it is on the screen, and that's what they think they want to have,
Right.
they're happy.
Well, and here's the other thing. It may not be the TV. It may not be the TV that's lying to you. It may be the source that's lying to the television.
With, yeah, fake metadata.
Fake metadata. And so at that point, unfortunately, without having an actual tester on the truck, which again, that's another thing when we go back and do that episode, which will be, I believe that's
Friday?
this coming Friday, we're going to do that episode.
We're going to try again.
Which we're going to be moving our time to 2 p.m. Eastern time. That way our friends over on the West Coast will be able to check in with us later on in the day. It's a little early for them at this time of day, so we're going to be moving things back a little bit so we can get as many people on here as possible. So this Friday at 2 p.m. Eastern time, which I think works out to be 11 a.m.
It does.
Western time, or Pacific time, we're going to be doing our episode on
Western time
on truck.
What you should
Truck Day.
have in your kit. And by the way, there's an excellent article on that. I believe it's either Remote Central, I think, has a small kit article running or thread running right now, which is great.
It's a perfect time to go look at that. So, guys, with that, I think we need to wrap up a little bit.
Let's do a couple other things. Let's talk about fiber.
Oh yeah, real quick. Let's go and do that.
Because we do have an 8K fiber, and we showed it at CES. And this is very exciting. Again, we don't have a CTS, so what we are looking at is what does the display demand from us?
Right.
We know the equalization capabilities of the television. We know its peculiarities. We know what the hardware expects. So it is possible to build for that. And my guess is we're probably not going to see a CTS till CES because of what's happening. They had originally said June, but they said June last year and the year before last.
Yeah.
So my guess is honestly is going to be CES before we see a real CTS for cables. However, that should not freak you out. It doesn't need to panic you. The world will continue forward because we know what the hardware demands.
Right. If you want a movement that you can get behind, do a hashtag CTS at CES. Let's do that. I mean, we'll get something like that started, right?
Yeah, no, that one's going to bite me in the hind.
Oh, no.
That one's going to bite me. But know that you can start wiring your customers' houses right now.
Yes.
Legitimately and safely.
Yes.
For 8K, up to 300 feet.
Yeah. Yeah, definitely.
So you can be there now. What you cannot do now is say, so I'm going to put an 8K matrix in.
Yep.
I'm going to put an 8K AVR in. You cannot do that yet today.
Yeah.
The sad note, just for what it's worth, is I can promise you 8K matrices are going to be a substantial jump in cost because the material substrate required for 8K is a whole lot more money than the board substrate for 4K.
Well, that was just like it was in 4K. When we jumped from 1080p to 4K, you saw a huge increase in price. But
and over time,
things come back down.
It comes back. Like gas was $1.81 a gallon this morning.
It was, wasn't it? That was kind of nice, wasn't it?
Yes, it was.
We're going to look back on this video.
We're going anywhere, but
you know,
if I'm going to buy gas.
Yeah. Well, we're going to look back on this video and be like, man, it was $1.81.
Wow.
Nice, right? All right.
And 6 feet apart. Excuse
me. Yep, there you go. All right, guys, thanks for checking in with us. Thank you for the questions. We're going to go through and see. Keep asking your questions. We're going to keep this chat going.
And said last week's winning question, I don't remember who asked it.
Yeah, well, we'll look it up.
Was the iPad in question, which definitely took us to this. And remember, would you switch me back to the overhead real quick? It's all about time. Originally, we had more time to develop the iPad. As the resolution increases, the time gets smaller and smaller and smaller. Time equates to voltage because how much time do we have to go from this state to this state, from there to there? And as the time shrinks, the voltage also has to shrink. So the TVs and the sources have to become much more discriminating.
Right. So.
I think that about covers this week.
I think so.
I'm Brent McCall.
I'm Adam Rogers.
And we're socially distancing.
Yeah.
Have a good day.
We'll see you guys on Friday, 2 p.m. Eastern time, where we're going to talk about truck day and figure out what you need to put on the truck.
Socially distancing.
Yeah, pretty much. Thanks, guys. We'll see you.